So here I received some more electronic goods in the form of donation, and I pulled this thing out of the box, this old Magnasonic DVD player with many capabilities inside. So we're going to disassemble the unit here, and inside what we should find is a dual semiconductor laser in the form of gallium aluminum arsenide factor, and it has a wavelength of 650 nanometer red to 780 nanometer near infrared, which is a form of infrared radiation, with an output power of 7 milliwatts, but I'm not sure if that's max. It could be pushed a bit, with a beam divergence of 60 degrees. So first I'm going to go ahead and remove all of these screws here on this unit. So here are the internals of this DVD player here. Here's our warning sticker over here for invisible and visible radiation from the optical drive here, which is what we're mainly after. But we also get a power supply over here that we can harvest and we can test with our multimeter. And over here we have a digital supply board with all the processing and audio and video external connections as well. So yeah, let's start removing some of these components here. So here I've successfully removed the optical drive from the DVD player. And here I have the power supply that I've also removed from the DVD player. This through-hole design is quite nicely built. There's good spacing and isolation around the tracks there, so that's good to see. And it has a output voltage connection, multiple connections actually, 6 to 14 volts as well as 4 volts, so this will be super useful. So here I've went ahead and modified the power supply to output a voltage potential of 7 volts, and I have a 6.75 holding up quite well here. And I'm just using the signal to ground wire as well as the 6 plus positive wire. And yeah, it should work pretty well as a laser power supply source. So here I've taken that old power supply from that DVD player and hooked it up to a custom-made driver that I put together, consisting of this 7805 linear regulator. And I've got that powering up this incandescent bulb here. And it's quite stable in terms of operation. It gets slightly warm, if that, and it remains between 5.63 to 5.67 volts here. This is just one of the nifty things that you can do with old power supplies from DVD players. So here I've connected the power supply to a custom driver that I put together using the LM33AT semiconductor and also using a 33k ohm resistor. And I have a white LED currently hooked up there, which is running quite nicely. I can switch to a red LED. An orange LED, and a blue and green LED here. Both are running continuously together. No problems whatsoever. So effectively, this power supply and driver should be ready to go here. So here's the optical sled from that DVD player. Now I can start disassembling. So here are the components that are removed from the optical sled. I have the optical components here as well as the laser diode component here. It's just a single closed canister laser diode here with red and infrared emission. All you have to do is desolder the pins there from the PCB board. There's the original circuit for the laser diode, as well as the photodiode here, which we won't need. All we need is the convex converging lens for focusing the laser diode to a focal point. So here I have successfully removed the PCB ribbons off of the 4 pins of this laser diode here using a vice press. What's interesting about these aluminum gallium arsenide laser diodes is that they're quite similar to some of the first gallium arsenide laser diodes that were ever made. The only difference is that these tend to have a much larger band gap, but the lattice constant is quite similar, if not the same. So before I power up the laser diode here, there's actually a simple laser trick that I can do to determine the wavelength of the laser. There's an AR-coated lens at the output of the canister there, which is a closed canister. And if I reflect the AR-coated lens in visible light, see that? We see a bluish reflection there, which is actually consistent with red laser diodes. So here I've successfully connected the laser diode in circuit here using the original power supply and my custom driver here. As you can see, we have a brilliant red 650 nanometer red glow there. So this should work very well as a power supply source and driver for making the laser diode module. Here's the output emission of the infrared light. Alright, so here's the preliminary setup using this DVD laser diode. I just have the laser diode heat sinked here to this big sink. And I've got a converging lens, which is the lens that I showed earlier. And I've got that outputting the red emission here. It actually has a fairly good distance with just the converging lens there. At least able to do some simple laser experiments and show you what the laser looks like with the lights off. Here's the laser output emission with the lights off. Here you can see scattering effects of the laser here. So here you can see the output beam is actually being polarized by this fluorescent and thick solution that I've put together here. It's composed of a fluorescent dye as well as basically baby shampoo, which has a relative thickness and makes the beam stand out more during the exposure here. You actually see the beam reflecting off the other side and effectively creative two beams there, just with a reflection and some refraction, of course. Here you can see more of a better view from the top of the jar here. That beam really sticks out in the solution here.